So we have a ball at the end of a thin light rod. So M equals, this is the mass of the ball, 350 grams or 0.350 kilograms. And it's ball on end of a thin light rod. And at this point, we have R as well, the radius of the ball, 1.2 meters. And then we have the moment of inertia of the ball. So because it's not the moment of inertia, don't get confused with the moment of inertia of a sphere and this situation. This situation, a ball is on the end of a thin light rod, and the rod itself is rotating. The ball is simply a mass at the end of the rod. So in order to find the moment of inertia of the ball, you simply have mr squared. That's it. No, it's not the moment of inertia of a sphere, because that would mean that the axis of rotation is through the ball instead of the axis of rotation is actually at the center, at the end of the other end of the rod, while the ball is at the rather the axis of rotation is at the beginning point of the rod, while the ball is at the end of the rod. That's why it is mr squared and not the moment of inertia of a sphere. So that would be, again, 0.350, 1.2 squared, and this is going to be 0.504 kilogram meters squared. At this point, well, actually, this would be the answer for A, mr squared, simply. And then they're asking us, well, we have a force of air resistance. This is going to be negative 0.020 newtons. And then it's asking for the torque. So the torque needed in order to, let's find the torque of the air resistance. So F air times R equals negative 0.020 R 1.2. And this is going to be negative 0.024 Newton meters. However, because the ball is in uniform circular motion, ball is rotating with constant angular velocity. So tau min would simply equal the torque of the air resistance on the ball, which is negative 0.024 newtons per meter. But in order to counteract air resistance, it's going to have to be positive instead of negative. So instead of negative 0.024, it'll be positive 0.024 in order to cancel out the air resistance. And again, this only occurs when the ball is rotating with constant angular velocity. This is extremely important. So this would be your answer for B, and this will be your answer for A. And that's the end of the solution. Thank you for watching.